Hey everyone, in this video we will go over the frequency divider. So let's dive in. We have a clock. Let's assume our time period is 1 nanosecond and we want to generate a clock with time period of 2 nanoseconds. So how can we do it? Actually, the solution is pretty straightforward. We take the output of the D flip-flop and we insert it with an inverter to the input of the D flip-flop. Let's see how it works in the waveform. Let's assume we started at 0. At the first positive edge, we transition from 0 to 1. Clock edge transitioning from 0 to 1. This clock divided by 2 will stay high until the next positive edge, and then it will transition from 1 to 0, and so on. Now, let's say we want to create a clock divided by 4. How can we do this? The solution is also pretty simple. You take the new clock from the previous clock divider and you insert it to the new D flip-flop clock. And we get practically the same thing. Let's see the waveform. Let's assume we started at 0. At the first positive edge, we transition from 0 to 1. From 0 to 1. We stay high until the next clock edge. Then we transition from 1 to 0, and so on. If you enjoyed the video, please subscribe to the channel. It helps the channel grow, and I will create more content that could help you. Let's look at our SystemVerilog code. So frequency divided by 2. We have a clock, we have a reset, and we have the clock divided by 2. We have an always flip-flop. It gets the positive edge of a clock or the negative edge of a reset negative. If we have a reset, we reset the clock divider. But if not, we will invert the output each time and get it out. Clock divided by 4 I solved in two ways. The first way is actually using the previous clock divided by 2. So what do we have here? We have our first instantiation of the first flip-flop and a second one for the second flip-flop. The first flip-flop gets the original clock, gets the reset, and the output is this Q1. This output Q1 is the new clock of the second flip-flop. So we put it here where the clock is. We get the same reset, but the output is going to be divided by 4. Another way to do it is straightforward, just coding it. So let's create a first flip-flop. Again, clock and reset. If we have reset, our output of the first flip-flop is clock divided by 2. It's going to be 0. Else, every time we're going to invert the output. We're going to take this clock and we're going to make it the clock of the new always flip-flop. Every positive edge we get in, or every reset. If we have a reset, we reset the clock divided by 4. And if not, we will invert the output each time we get this positive edge clock. Waveforms. So this is our original clock. We have a reset. Let's look what happens after the reset. So clock divided by 2, we get our first positive edge. We can see we transition from 0 to 1, and it stays 1 until the next positive edge, and then transitions to 0, and so on. If we look at that divided by 4, so it's the same. We just look at the clock as the divided by 2. So we see the first positive edge, we transition from 0 to 1, and then we stay 1 until the next positive edge, and then we transition from 1 to 0, and so on. I hope this video was helpful for you and that you enjoyed it, and please follow for more and let me know what other kind of videos you would want me to create.